Hello friends, this video on structure of atom part 27 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 26. So we'll talk about some orbitals and quantum numbers actually. So if you see, there are large number of orbitals possible. There is something called shell, and then we have something called subshells, and then we have something called orbitals. I'll discuss all this. So for example, you have n is equal to 1, 1s, that is the shell number 1. In that you have subshell, s is the subshell. And then you have orbitals, in this case you have only one orbitals. If you talk about 2, n is equal to 2 is a shell, there you have two subshells, s and p. For s subshells, right here, for s subshells, there is only one orbital. For p subshells, if you see, there are three orbitals, px, py, pz. I'll show you. This is the this is px, py, pz. There are three orbitals in three different orientations. Sorry, pz also. Sorry, only three only. And then if you talk about third subshells, you talk about third subshell, then you have, for example, if you talk about third shell, then you have SPDS subshell. For S subshell, there is only one orbital, P. For P subshell, there are three orbitals, PX, PY, PZ. For D subshell, there are five orbitals actually. See, one subshell, 2, 3, 4, 5. They're all for D. This is all for D. So each orbitals will have two electrons. That's how it is. So you have shells, subshells and orbitals. We'll discuss more about this. These orbitals can be distinguished by their size, shape and orientation. You see, the size will differ, the shape will differ, or the orientation will differ. So if you see in these all cases 1, 2, 3, 4, the size and shape is different, same, but the orientation is different, right? This and this, the size and shape, orientation, everything is different. So you can distinguish these orbitals by their shape, size and orientation. Orbital of smaller size means there is more chance of finding the electron near the nucleus. So if you see, if this is smaller orbital, that means, for example, in this case this orbital is small, that means you have more probability of finding the electron near the nucleus, right? Similarly, shape and orientation means there is more probability of finding the electrons along certain direction. That means I'm saying that if there is this is my p orbital, right? That means there is a high chance of finding electrons in this, right? In this shape, because there is nothing like this shape. The shape doesn't exist actually in real, but it's all about the probability. The probability of finding electron in this region is more. The probability of finding electron in this region is more. The probability of finding electron in this region is more, and that's how it is, right? It's all about the probability of finding electron along certain direction and certain space. And atomic orbitals are precisely distinguished by quantum numbers. We'll discuss this quantum number. So we can easily distinguish the atomic orbitals by the quantum number. For a given quantum number, we can tell what will be the shape of the atomic orbital, how far it will form nucleus, and all this stuff. So quantum number, there are 4 quantum numbers, and that gives the exact orbitals. And each orbitals is designated by 3 quantum numbers actually, n, l, m, n. There are 3 quantum numbers. A combination of this will give you one unique orbital. Hope you understand this. There are so many orbitals, and they're just a wave function. This is the probability of finding electrons, and 3 quantum numbers will give you one orbital. We'll explain more when we go understand what is the value of n, l, m, n. First, let's differentiate the between orbit and orbital. Orbit is something which is given by Bohr, and this is given by quantum physics. Actually, orbit doesn't exist practically. This orbit is just a concept. Actually, if you see the atom, there is no orbit. Orbitals, these orbitals, they exist, but they don't have any physical meaning. They are nothing but wave function psi. In this theoretical concept of orbit, Bohr defined orbit as well-defined circular path around the nucleus in which electron moves. Orbitals are nothing but a quantum mechanical concept and refers to one wave function, as it's nothing but the three-dimensional space around which there's a high probability of finding electrons. Three-dimensional space, and it's nothing but a wave function. This orbit concept contradicts with the dual nature of electron. This doesn't contradict. The orbit nature contradicts with the uncertainty principle. This doesn't contradict. All orbits, the theoretical orbits, were like a disk. For example, this is, see the disk space. But the orbitals can have various shapes. SPDF will explain the different shapes we have for orbitals in the next few slides. The maximum number of electrons in an orbit is 2n square as per the theoretical formula by Bohr, and the maximum number of electrons in the orbital is 2. Please note the maximum number of electrons in an orbital is 2. For example, in this they will be at the max 2 electrons. One may be here, one may be here, or anywhere, right? There may be 2 electrons at the max.
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.